Hello students, welcome to my channel. In this video I am going to teach you very important questions. Dear students, I have already told you in my previous video that the questions which are related to sum are categorized in 5 different types, and in my previous video I have already taught you type 1, first type, and that is the sum of this type of series. So dear students, today I am going to discuss about type 2, that is related to sum of infinite geometric series. So there are so many infinite series, but here we can find the sum of only geometric series, infinite geometric series, which satisfy a certain condition. So before starting this type 2, let's take some examples of geometric series. Here geometric series. So geometric series means the series where the ratio between a term to its preceding term. That means suppose 2, 4, 8, 16, 32. Common ratio here, common ratio, that is denoted by R, and that is always ratio of a term to its preceding term. So what is the preceding term of T2? T1, or that is T3 by T2, or that is T4 by T3, and so on. So here what is the ratio? 4 by 2, 4 by 2, that is 2. So here 8 by 4, 8 by 4, that is also 2. 16 by 8, 2. 32 by 16, that is 2. So in this way we can find common ratio of the geometric series. So let us take one more example. 1 minus 1 by 2 plus 1 by 4 minus 1 by 8, and so on. Here what is the common ratio? T2 by T1, so minus 1 by 2 by 1, or 1 by 4 by minus 1 by 2. So from here we got 1 by 2, and from here we got minus 1 by 2. Here common ratio is minus 1 by 2. Similarly, the students, 3, root under 3, 1, and so on. This is also geometric series sequence. So here what is the common ratio? Root 3 by 3, and this is 1 by root 3. Why 1 by root 3? This is root 3 square, root 3 cancel, 1 by root 3 left, and from here also you can get 1 by root 3. So this is common ratio. So in these 3 examples, look here, this is 1, 2, and here 3. I took 3 examples. From these 3 examples, we got, in first example we got common ratio 2, in second example we got common ratio minus 1 by 2, and in third example 1 by root 3. So here these all are geometric sequence, this sequence or series. So here if the common ratio, absolute value of common ratio is less than 1, if the absolute value of common ratio is less than 1, then only we can find sum of that series. So here is common ratio 2, so its absolute value is also 2, but that is greater than 1, so we cannot find its sum, not possible. So here what is common ratio? Minus 1 by 2. So what is absolute value of minus 1 by 2? This is 1 by 2. So this modular sign, this is absolute value, it makes this minus plus. So here 1 by 2 is less than 1, so absolute value of common ratio is less than 1, so that's why it is possible to find its sum. So we can find its sum. Similarly, look here, 1 by root 3, and absolute value of 1 by root 3, this is 1 by root 3. 1 by root 3 is less than 1, so this also satisfies this condition. That's why sum of this sequence is also possible. So students, if the absolute value of common ratio is less than 1, then we can find sum of that geometric series. So students, to find the sum of infinite geometric series, we know that the absolute value of common ratio must be less than 1, that is absolute value of R must be less than 1. This is very important here. If this condition is satisfied, then only we can find the sum. So let us take one example here. Find the sum of 5 plus 5 by 2 plus 5 by 4 plus 5 by 8 plus, and so on. This is infinite series. Its common ratio, what is its common ratio? Here R, solution R is T2 by T1, so 5 by 2 by 5, so this is 1 by 2. So here, since absolute value of R equals to 1 by 2 and this is 1 by 2 and which is less than 1, so sum can be found. So students, here we got common ratio, absolute value of common ratio is less than 1, that's how we can find its sum. So to find sum, now we have one formula, sum of infinite series. So this infinite means here are infinite series numbers, so that's why we use here S infinite, and it has one formula, a by 1 minus r. So this, by using this formula we can find sum of infinite geometric series. So here a represents first term. What is first term? This is a, this is a. So 5 by 1 minus r, what is r? 1 by 2. So in this way, students, we can find sum of infinite geometric series. So if we add all the terms of this series, then their sum is 10. So students, in this way, by using this formula, we can find sum of infinite geometric series. Students, look at one more example here. We have to prove this. Actually this is not series, but here we can make series in power. So in solution we have to prove, that's why let's take LHS. What is LHS? 3 power 1 by 3 into 3 power 1 by 9 into 3 power 1 by 27 and so on. And this, in all the terms, bases are same, that's how we can add their powers by laws of indices. So here are infinite terms, that's why power source also goes to infinity. So in powers, look at here, here is one geometric series. Now taking, we can take here 1 by 3 plus 1 by 9 plus 1 by 27 plus to infinity and so on. So here r equals to, here a equals to, what is a? 1 by 3 first term, and r equals to 1 by 9 by 1 by 3, so 1 by 9 into 3 by 1 and we got 1 by 3. Since look here, absolute value of r 1 by 3 and this is 1 by 3 is less than 1, since absolute value of common ratio is 1, sum is possible, we can find its sum. So now use formula. Again we can use formula as infinity equals to a by 1 minus r. What is a? 1 by 3. Here is a 1 by 3, 1 minus 1 by 3, here common ratio is 1 by 3 we have found here. So 1 by 3 after solving this, so here 1 by 3 into 3 by 2, 3 cancel, so 1 by 2 left. So here this 1 by 2 is in power, so LHS equals to, what happened here, 3 power 1 by 2, and this is root under 3, and that is to prove here, and this is right hand side. In this way we can prove this very important question. Dear students, let us take one more example. Example number 3, if modulus of x is less than 1, absolute value of x is less than 1, and we have given here one sequence, we have to prove this. So solution, what is given here? Y equals to x plus x square plus x cube plus and so on, and here this is geometric series because common ratio is x. Here r equals to t2 by t1, so x square by x, and this is x. And here we have given one condition, absolute value of x is less than 1. So this is common ratio, since absolute value of r equals to absolute value of x, because this is common ratio. So this is less than 1, so we can find sum. Now use formula s into a by 1 minus r. What is a? This is a is x. 1 minus r, what is r? X. So here what is to prove? X equals to y by 1 minus y. So s infinity. So in question we have given x plus x square plus x cube plus dot to infinity. So sum of this series is y. This is yes infinity. So here we can put y. Now cross multiply. Y 1 minus x equals to x. We got here y minus xy equals to x. So we have to bring value of x. So y as it is, x plus xy. So y as it is, x is common, 1 plus y. Therefore x equals to y by 1 plus y. So proved. In this way we can prove the questions. One very important question here. This may be asked in 6 marks. The sum of infinite number of terms of a GS is 15. Here one sum is given, and the sum of their squares is 45. Find the series. So to find the sum of infinite geometric series, we need first term a and r, because s infinity equals to a by 1 minus r. Okay. Here we need a and r, but this question we don't have a and r. We have just sum. That's why we need to suppose here solution. We need to suppose geometric sequence or geometric series, and a and r be the first term and common ratio. Then what is geometric series? ar square, ar cube, ar power 4 and so on, because we need here infinite geometric series. Okay, here first condition. What is first condition? So according to first condition, sum of infinite number of terms, that means a plus ar. Okay, here I left one term, plus ar square and so on, this equals to 15. So this is geometric series, and here its formula is s infinity equals to a by a is first term a 1 minus r, common ratio is r, equals to 15. So from here get a 15 1 minus r. This is equation 1. So it's condition. What is second condition? Sum of their squares. So what is first term? A square. What is second term? ar square. What is third term? ar square whole square and so on, and its sum is 45. So here this is a square r square, a square r power 4 and so on, and it is 45. And here r, this is also geometric series, so it has also sum s infinity equals to a by, so a is a square here 1 minus r. So what is r here? R square equals to 45. So students, we have got here value of a. So let's suppose this equation 2. Okay, now we have two equations 1 and 2. So by solving these two equations we can get first term a and common ratio r. So from 1 and 2, so here value of a is 15 1 minus r, so we can put this, we can replace this a by this value. So 15 1 minus r, so whole square 1 minus r square equals to 45, or 15 square 225, 1 minus r whole square. We can open this in bracket, a square minus b square, so this is 45, so you can cut this here. 225, 1 minus r, 45, 1 plus r. So students, simplify this. 225 minus 225r equals to 45 plus 45r. Putting this from 1 again, from 1 we get a equals to 15, 1 minus 2 by 3. Okay, if you simplify this, you will get its value 2, 3, 1 by 3, 5 only. So after we got value of r and value of a. So here we have to find the series. We have already supposed geometric series a plus ar plus ar square. Now replace the value of a and r here, then you will get your series. Therefore, or hence, the series is first term 5 plus ar square, because geometric series is a plus ar square plus so on. A, this is 5 plus a, 5 into r, 2 by 3 plus ar, this became 2 by this, 5 as it is, r square 2 by 3 whole square. So in this way, after simplifying this, you'll get 5, 10 by 3 plus 20 by 9 and so on. This is our answer. So this is very important question. Students, here is one more important question. Find the sum of this. But this series is not a geometric series. This is not a geometric series. We can find its sum by using the sum of infinity formula. So let S infinity be the sum. So here we can write S infinity 3 by 5 plus 4 by 5 square plus 3 by 5 cube plus 4 by 5 power 4 plus 3 by 5 power 5 plus 4 by 5 power 6 and so on. Okay, this is given. Students, we can do this question by two methods. The first method is you can take LCM of these two in this way. So here LCM is 5 square, so here 5 goes 15 plus 4, and here 5 power 4 LCM, here goes 15 plus 4, and here 5 power 6 LCM, here 15 plus 4 and so on. Okay, here students, this became 19 by 5 square, this is also 19 by 5 power 4, and this is also 19 by 5 power 6 and so on. And here 19 by 5 is common, 5 square also. So what left here? 1 plus 1 by 5 square came out, so 5 square left here, here 5 power 4 left and so on. Okay students, this is 19 by 25. Now this became geometric sequence. Use formula. So what is the formula? A by 1 minus r. So a 1 minus r 1 by 25. So 19 by 25 into 1 by 24 by 25. So this become 19 by 25 into 25 by 24. So in this way you got 19 by 24. This question can be done by another process alternatively. So here students, if you take 3 by 5, 3 by 5 cube, 3 by 5 power 5 in one bracket, and similarly this 4 by 5 square, 4 by 5 power 4, 4 by 5 power 6 in another bracket, then take 3 by 5 common, 4 by 5 square common. After taking common, you will get two infinite series like this, and use formula and simplify, you will get same result. By that process also you can do this question. In this way students, we completed type 1, and we have already completed type 1 in my previous video. I'll bring the remaining 3 types in my next videos. Thanks for watching this. If you liked or if you enjoyed this video and want to see more, please like, share and subscribe my YouTube channel. Thank you.